Hello and welcome. We are still studying elements and properties and occasionally going back and looking at the periodic table. We are looking specifically at metals this time, and we are on page 518, I believe it is. Now what I'd like you to do is take a look at this. And the way we're going to look at it is we're going to take a look at the pictures and look at what's expected of us for this chapter. Okay, we are in section 1. And here are the questions I want you to look at and understand. Jot them down. Take a moment, pause the video if you have to, and jot them down. Here's what we want to find out. What are the properties of typical metals? That's going to be one of the things we have to find out. How do atoms bond in a metallic bonding? That's another thing we're going to be looking at. Jot that down on the left side of your notebook, and when you come across it, if I talk about it, if you hear it in class, I want you to answer that question then. How do atoms bond in metallic bonding? Next question. Which elements are alkali metals and which are alkaline earth metals? And what are some of the common uses of transition metals? Okay, just a little review. Remember, a group is the vertical column in the periodic table. That's the column going up and down. Now, here are some of the words we're going to be looking at. We're going to be looking at things like metal. What is a metal? The word malleable. Ductile. Metallic bonding, radioactive elements, and transition elements. So pause the video and write those down. And make sure when you come across the definition, you answer these questions as well. Okay? Now let's start off like we always do by looking at the pictures. We'll look at the pictures in this section and then move to the next page and see what the pictures are there. This says in Figure 1, the various properties of metal make them useful. And what do we see? Some of the uses of metal are sheets and wires. Now here's a big metal sheet. What do you suppose that sheet could be used for? It's a big old sheet of metal. Well, maybe they stamp it into a door of a car. Well, that'd be one thing they could do with it. It looks pretty thin there, but I bet you they can make it thicker if they want. It looks kind of papery there. Maybe it's even aluminum foil. I don't know what it is. Metals are malleable, the picture says. They can be hammered into thin sheets. So that's a good word right there, malleable. And it's one of the words we were looking for. If a metal is malleable, it can be hammered and made into different shapes, in this case, thin sheets. Oh, look, here's some wire. It says here metals are ductile. They can be drawn into wires. And in class, I told you what drawing something it's like. It's like taking a piece of taffy on a warm day and just pulling that taffy. It doesn't break right away. It just gets thinner and thinner and thinner and thinner. Then eventually it breaks, but it gets nice and thin like spaghetti before that. So let's go back. Well, before we even go back, let's go to the next page and see if there's any pictures that we're going to be coming across. Okay, let's go to the top. Okay, and here's a picture on the right-hand side. It says sodium chloride crystal. Now, sodium chloride, right off the bat, it tells you that there's two different elements in here. There's sodium and there's chloride, and they're making a crystal. Now, sodium chloride, you know what that is? It's salt, plain old salt. And if you look at this, it says metals can form ionic bonds with nonmetals. Okay, well, what's the metal? Sodium is a metal. It's on the left side of the periodic table. Left side of the periodic table is sodium. And on the right side is chlorine. Okay, it's not a metal. It's a nonmetal. And they can be mixed together, and guess what we have when it's all mixed together? We have salt. All right, let's see if there's any other pictures before we come to the end of this section. Matter of fact, let's go down to the bottom here. I think I saw a picture. Oh, there's a picture of sodium atoms. It looks like it's all sodium atoms, nothing else. So this must be a sodium element because there's nothing else mixed up with it. And it says here, figure 3, in metallic bonding, the electrons in the shared electron C are not attached to any one metal ion. This allows the electrons to move. So you can see the kind of light blue cloud here. Let's pretend that's where the electrons are. And they kind of move together. Okay, so these are kind of moving together. And it says here that in metallic bonding, I'm going to read it again, the electrons in the shared electron C. Oh, they're calling this a sea of electrons. Kind of like icebergs in the middle of a sea. The electrons in the shared electron C are not attached to one metal ion. Okay, so these aren't attached. They're kind of floating around. So all these guys think they have there's 7 electrons in the outer shell, but in fact they do, but they're kind of loose and free and flying around. Okay, so this has already given up its 1 electron rather. I said 7, I meant 1. Remember, sodium is on the left-hand side. It has 1 electron in its valence shell, and this guy's he spit it out already. So he's free. Remember, he wants 8 in his valence, in his outermost shell, so he spits out that 1, and they're all kind of floating around here. Are there any other pictures? Let's see. Oh yeah, here's another couple of pictures. Alkali metals are very reactive. For example, the vigorous reaction between potassium and water releases enough thermal energy to ignite the hydrogen gas that forms. Wow, look at this. So this is alkali metals. That's the first column. See it right there? Alkali metals. This one right here, the first column. Okay, only 1 electron in the outer shell, remember? And wow, this thing really reacts with water. Kind of blows up. So you can see the white flame right there. Are there any other? All right, let's go to the next page and see if there's any other pictures we want to see. Move to the top. The alkaline earth metals. Okay, this picture tells us, oh, they're in the second group. That's good to know. And let's see. Oh, here's another picture. What does this tell us? It says in figure 5, alkaline earth metals make spectacular fireworks. So that's column 2. They make fireworks. The labels on each burst indicate the compound that is primarily responsible for the color of the firework. Wow. So red is compounds of strontium or lithium makes red. Yellow are compounds of sodium. Do you know that sodium was up in fireworks? I didn't know that. Orange compounds of calcium. White, magnesium or barium oxide. Well, that's kind of neat. Okay, let's go to the next page and see if there's any more pictures we want to know about. Here's more pictures. I think these are the transition metals. Well, I think we did enough for now. Let's go back to the first page and let's start reading together what it says. Okay, remember, you're going to stop the video, write these questions down if you have to, if you haven't done so already. Okay, so here is the main idea. Here's the part that we want to understand. It says metals are located on the left side of the periodic table. On the left. Okay, so my notes would say metals are on the left side of the periodic table. They're generally shiny. That means usually they're shiny. They're malleable, which means you can shape them into thin sheets. They're ductile, which means you can turn them into wire like pulling taffy. And they are good conductors. Okay, so let's read on. And you feel free to read all this. Matter of fact, I'll go through it with you. Real world reading link. Grocery stores set aside different areas for different types of food, such as vegetables, meat, and dairy products. In a similar way, scientists classify the elements into different groups. So this is back to our periodic table again. And it says metals are elements that are shiny, malleable, ductile, and good conductors. Now, we talked about this a lot. So right there, good conductors. Maybe I can mark that. Let's see if I can mark it good. Good conductors. Okay. The shiny properties of metal is called the metallic luster. Now, you don't have to know that. Okay, I'll circle it anyway. Here's one. If they're in yellow, you really have to know them. So here's a yellow one. It says metals are malleable. Okay, which means they can be hammered or rolled into sheets. Metals are ductile. There's another one that we have to know. It says, which means they can be drawn into wire. When I'm saying drawn, it's like drawing with this little crayon I have here. It means pulled, like you draw water up from the well. Okay, it's pulled up. Now, these properties make metals suitable for use in objects ranging from eyeglass frames to computers to buildings. All these things are made from metals, some part of them anyway. The specific properties of a metal depend on its unique configuration of electrons, protons, and neutrons. The three elements, the three particles of an element, right there. Electrons, protons, and neutrons. It says elements in the same group of the periodic table have similar properties. Metals in the periodic table. In the periodic table, metals are found to the left of the stair-step line. Okay? So let's go see what they mean. We'll look in a second. Well, I'll tell you what. Let's go look now. Let's see. I thought we had a picture of the periodic table. Well, I'll show you what that means later. If you look on the periodic table, toward the right side, about 3/4 of the way, you'll see the steps highlighted. We've done this before in class, but you should be able to see it and see it highlighted right there. I can't pull it up right now, but I'll show it to you in class. Okay, in the periodic table, in this book, the metal elements blocks are colored blue. So I want you to go look at those. Pause this if you have to, and go look at the periodic table in blue. Notice that the blocks are colored in blue, rather. Notice that most elements are metals, except for hydrogen. All the elements in group 1 through 12 are metals, as are the elements under the stairs step line in groups 13 through 15. Okay, so we just read this. The important things I want you to know. I want you to know what a metal is. I want you to know that it's good conductors of heat and electricity. I want you to know it's shiny, has properties that are shiny. Let's make sure we underline that too. They are shiny. Okay. And that shine is called a metallic luster. They are malleable, meaning it can be shaped. They're ductile. Okay. So those are the three words I want you to really understand and memorize. Now let's go on. Bonding in metals. Okay, the atoms of metals generally have 1 to 3 electrons in their outer energy level. Okay, 1 to 3. That's what they usually have. In chemical reactions, metals tend to give up electrons easily because they are not strongly held by the protons in the nucleus. Now remember, the protons are positive and the electrons are negative. That's what causes them to attract. But sometimes the thing that's holding them together, that attraction, is kind of weak, is what it's saying. Bonding with nonmetals. When metals combine with nonmetals, the electrons of the metals tend to lose electrons to the atoms of nonmetals. Well, you remember that. Remember the sodium spitting out that one element, that one electron in the outer shell, that valence shell? And you remember the chlorine grabbing it. Well, that's just what they're showing here. So they're showing nothing new. This is what we've talked about before. And we've talked about making salt, sodium chloride. So we know all about that. Okay. Metallic bonding. Now, remember that was ionic bonding, what we just talked about. Bonding with nonmetals. This is ionic. It's formed by plus ions linking up with negative ions. And remember, the plus here is because it has it spit out one proton. See the hand there? It spit out one. I'm sorry. It spit out one electron, and this guy grabbed one electron. That's why it has an extra negative here. This guy lost an electron, so he's positive. And remember, you cannot lose protons, or else the element isn't what it was before. So sodium has to keep all its protons, and chlorine has to keep all its protons. Okay, here we go. Metallic bonding. A different type of bonding occurs between the atoms of metals. In metallic bonding, remember, that's a word that you have to define. That's a word you should write this down. If it's in yellow here, it's important. In metallic bonding, positively charged metal ions are surrounded by a sea of electrons. Okay? Outer level electrons are not held tightly to the nucleus of an atom, but move freely among many positively charged ions, as shown in figure 3. There it is. So those electrons are just floating around here, and these are all ions. So each one of these sodium spit out an electron, and they're just looking for a place to go. They haven't gone anywhere yet. Okay? Metallic bonding explains many of the properties of metals. For example, when a metal is hammered into a sheet or drawn into wire, it does not break because the ions are in layers. So all these things kind of form layers that slide past one another without losing their attraction to the C, electron C. So, in other words, I suppose it's like, let's see, what can we make it think about? Let's see. It's like taking jelly and putting it on a piece of glass and squeezing another piece of glass right on top of it. You can see it spread right out, but it doesn't really break or anything. So as long as that jelly is between two pieces of glass, you can see it spreading out, but it doesn't break. Well, that's kind of like what this is. Okay, but it's metal. This is metal this time. Metal are also good conductors of heat and electricity because the outer level of electrons are weakly held and travel relatively freely, which means if I have an electric battery over here and I push in an electron, one pops out from this side because these guys are all loose. That's what makes them a good conductor. And here's the first column. Oh, there's those steps that I was looking for. See the steps? So these are all metals all the way to the left, okay? And now we're talking about the alkali metals. Okay, that's the first column. The elements in metal group 1 of the periodic table are called alkali metals. Like other metals, alkali metals are shiny, malleable, ductile, and good conductors of heat and electricity. However, they are softer than most of the other metals and are most reactive. They're the most reactive metals. You put sodium in water, and what did we see in the picture earlier? It catches on fire. They react rapidly and sometimes violently with oxygen and water, as shown in figure 4. Let's see, is figure 4 down here? I think figure 4 is the previous page. Oh, right there. Figure 4. See it? Wow, look at the sparks flying off. Holy smokes. They react rapidly and sometimes violently with oxygen and water, as shown in figure 4. Because they are so reactive, alkali metals do not occur naturally in their elemental form, and pure samples must be stored in oil to prevent reactions with oxygen and water in the air. So you can't even have this stuff in the air because the air sometimes has moisture in it. Boy, oh boy, I hate to have this in my pocket on a foggy day. Wow. So we know that these are really reactive, and we know it's because they have one electron in that outer shell, and they want to spit that electron out, and they react very quickly. The atomic structure explains the reactive nature of alkali metals. Each atom on the alkali metal has one electron in its outer energy level. This electron is easily given up when an alkali metal combines with a nonmetal. Remember the salt? Sodium giving up an electron, chlorine grabbing it in. Okay, lithium, sodium, potassium. Look carefully at the nutritional information on a cereal box. You will notice that sodium and potassium are often listed. You and other living things need potassium and sodium compounds to stay healthy. Well, that's an important fact you may want to write down. We need these things to stay healthy. Okay? Okay, let's go down to the next part. It says rubidium, cesium, and francium, all part of the first group. The operation of some light detecting sensors depend upon rubidium or cesium compounds. So light detecting sensors, like the one in our room that turns the lights on, they detect shadows and that kind of stuff and turn the lights on. Cesium is used in atomic clocks because some of its isotopes are radioactive. A radioactive element, as a definition, this is what you have to write down. A radioactive element is one in which the nucleus breaks down and gives off particles and energy. Okay, listen to that. Listen to what it's saying. A radioactive element is one in which the nucleus breaks down, the protons and the neutrons. And you know what happens if you give up a proton, then the element is no longer what it was before. So that's what makes a radioactive element, the giving up of protons. Okay? And that's why some radioactive material turns into lead eventually, because it's giving up protons. Francium is also radioactive and is extremely rare. Scientists estimate that the Earth's crust contains less than 30 grams of francium at one time. Wow. That's kind of interesting. Really rare. Okay, and here's a few explanations of some of the other ones. Okay, we're not going to go through them all. These are the alkaline earth metals. The alkaline earth metals make up group 2 of the periodic table. Like most metals, these metals are shiny, malleable, and ductile. Like the alkali metals, they combine readily with other elements. Remember, they have 2 in their outer shell because they're in column 2. Each atom of the alkali earth metals has 2 electrons in the outermost shell. Hey, we just said that. These electrons are given up when an alkali earth metal comes and combines with a nonmetal. The alkaline earth metal atoms combines the positively charged ion in a compound. The alkaline earth metals becomes the positively charged ion in a compound. Well, just like the sodium gave away 1 electron. Remember, sodium's right over here. Well, magnesium gives away 2 electrons. So it's the same idea. And if it's mixing with fluorine, which is over here, fluorine only has 7 in its outer shell, so it would like 1. So if you're mixing calcium with fluorine, that's why it says Ca2, because this guy has 1 electron he gives off, and he gives it off to 2 fluorine atoms. That's what it's saying. I have 2 to give away. Well, here's fluorine with 2 to take it. 2 to take those free electrons. Some compounds of the alkaline earth metals are used to color fireworks, like those in figure 5. We just saw those. Okay, and here's magnesium. Magnesium is the lightest. Magnesium, I'm sorry, magnesium's lightness and strength make it a good material for cars, planes, and spacecraft. Household ladders and baseballs and softball bats and a whole bunch of things. Okay, so that's some of the uses right there. Right there, some good uses. Most life on Earth depends upon chlorophyll, a magnesium-containing compound that enables plants to absorb light and make food. Well, there are some uses for it right there. So if you want to put down some uses, this book tells you right there. That's what they are. Okay, so we got that. Calcium is seldom used as a free metal, okay, but its compounds are useful and essential for life. Marble statues and some countertops are made of calcium carbonate. Okay, and that's the symbols of it. Calcium carbonate. Okay, which says it has calcium, carbon, and oxygen in it right there. Calcium carbonate is the major component of the mineral limestone, which is found in many caves. You might take a vitamin with calcium. Calcium phosphates in your bones helps make them strong. So that's another good thing to know. Okay. And here are some other earth metals, but I think if you want to read this, go ahead. Well, this you should know also. Radium. The last element in the group 2 is radioactive, okay, and is found associated with uranium. It was once used to treat cancer, but is being replaced with more readily available radioactive elements. Okay, we're going to pause here, okay, before we go into the transition elements. Now, you had some questions to answer in the beginning. And I'm going to go back to that page because I want you to go back and take a look now and see if we've answered any of these questions. What are the properties of typical metals? How do atoms bond in metallic bonding? Which elements are alkali metals and which are alkaline earth metals? And what are some of the common uses of the transition elements? And that's we're going to get there. We haven't quite gotten to this one yet. So see if you can answer those first three.